Alright, so we want to take 3 pi over 7 and put it into each quadrant. So a reference angle of 3 pi over 7. And so, move that up there. Okay, so we've got 0 and pi over 2 and 3 pi over 2, and somehow that's selected. So how big is 3 pi over 7 compared to pi over 2? So think about this. If I want to put a 7 down here, I would have to multiply by 3.5. So pi over 2 is 3.5 pi over 7. Right? Now I could also just go to 14 and say that's 7 pi over 14 and that's 6 pi over 14, which lets me know I'm fairly high up here. And what's my reference angle? What are we doing in this anyway? So complete position angle, difference between complete polytable standing position angle between 0 and 2 pi. Oh, so is that all we're doing? Just putting it in the right place? Put it in its place. Okay. Ah. So I've got 2 people down in 302, but. A sec. Okay, so this angle, quadrant 1 angle is just the rotation angle, right? So you just say, so theta is equal to 3 pi over 7. Now, how many 7s is this guy here?
I'll put mine in the library, so grab it.
Sure, but you got to say how many 7s this is.
3.
Go to the library. So this is pi, so it's 7 pi over 7, right? And I need to be 3 pi over 7 short of that, right? I need this angle here to be 3 pi over 7. If this angle is 7 pi over 7, then what's this angle? That is 4 pi over 7. So a reference angle of 3 pi over 7 in quadrant 2 gives you a rotation angle of 4 pi over 7. Now here, this is again 3 pi over 7. So, okay, what was it to here again? How many 7ths? That's 7 7ths, so the rotation angle is 10 pi over 7, right? So we've gone 7 7ths, and then we have to go another 3. So here, we're 3 short of pi, but that's 3 short of 7 pi over 7, so we're at 4 pi over 7. And then here, excuse me, that's 2, not steep enough. So this is 3 pi over 7. So once around the circle is how many 7ths? 14 of them. So this angle is 11 pi over 7, right? Because you are 3 short, right? Like that's 14, back up 3, you're at 11. Okay? Okay, 1.2. What's the rotation angle? 1.2. And if I want units, I can put rad. I need this here to be 1.2, so what's this guy? And give it as an exact value. So, sorry? Pi, yeah, pi minus 1.2. You start working on the tau manifesto, right? Did I tell you about tau? So tau is 2 pi. Tau is just another Greek letter, right? And there's a movement amongst people for the circle to say, why not once around the circle be one thing, right? So they call that tau. So tau is 2 pi, right? And then a quarter is a quarter, and a half is a half. And life is easy, right? I mean, it makes sense. 1/12 of the way is 1/12 of the way. Right now, pi over 12 is 1/24 of the way, right? Because it's half. But we have to work with pi and that, so we're going to stick with pi. But tau has a certain appeal to that. So this angle is pi minus 1.2. And then to the nearest tenth, let's say we do it to the nearest tenth, it's 1.9 radians. So about 1.9. So here's 1.2 here. So what's my rotation angle? So pi plus 1.2, which is 4.3. About equal, right? About approximately. Hey, it's quieter than the electric ones. That's 1.2, so what's my rotation? 2 pi minus 1.2, right, which is what? 5.9? 5.1. Yeah. Who am I listening to? Okay, so just in terms of theta r then, right? We're getting an expression for the angle in terms of theta r. So in quadrant 1, theta is equal to theta r. The rotation angle is the reference angle. In quadrant 2, there's theta r. So what's the rotation angle? Yeah, pi minus, right? Like if I go out to pi, then I'm going to have to subtract off. So it's pi, or, you know, we are theta r short of pi, right? But go another theta r, you'll hit pi. So pi minus theta r. Theta r are here. So what's theta? Pi plus theta r. And remember, so remember the reference angle. It's always between the x-axis. Okay, don't start drawing it down between the y-axis. And what's my rotation? 2 pi, take away theta r. Okay. At some point, this is going to become second nature, as well as the whole radian thing. It's like, you know, months from now, it's like degrees. What's degrees? Right? We don't use degrees. If we do keep using degrees, they will be on stuff, but you'll just say, why? Why degrees? Draw the standard position angle, 2 pi over 3. So what quadrant is that in? So how many pi over 3's is this? 3 pi over 3. This one is 1.5 of them, right? We shouldn't really do that. We should go to 6, but it's 1.5. So 2 pi over 3 is in here. So there's the rotation angle, 2 pi over 3. 8 pi over 3. Where's 8 pi over 3? So how many pi over 3's in a complete circle? Try again. How many pi over 3's in a complete circle? 6 of them, right? And then how many more do I have to go? Okay. So that indicates the rotation, right? So this is 8 pi over 3. Negative 4 pi over 3. Where's that? It's the same angle, isn't it? Negative 4 pi over 3. And 14 pi. Okay, well there's 6 pi's, and then there's 12, and then go another 2. So what kind of angles are these? Coterminal. 14 pi over 3. So all the above angles are coterminal. When an angle's in radians, to find a coterminal angle, just add or subtract increments of 2 pi, right? So in degrees was 360 degrees. In radians, it's 2 pi. I want you to start thinking of 2 pi as 2 pi, 4 pi over 4, 6 pi over 3, 8 pi over 4, 10 pi over 5, right? Like convert it so that it has the same denominator as whatever you're working with. Okay, that'll become clear in a second when we start to do them, right? Go for it. Like here. So here's pi over 3's, right? So coterminal angles, right? 2 positive. So I got pi over 3. And what do I want to add? I want to add 2 pi. But we're not going to think of it as 2 pi. We're going to think of it as something pi over 3, which is 6 pi over 3. So I'm going to add 2 pi, right? But really what I want is pi over 3 plus 6 pi over 3, which is equal to 7 pi over 3. Okay? I want another one. So I'm going to go pi over 3, but how many 6 pi over 3's am I going to add? So I'm going to add 2. Now, these are 2 pi's, right? I'm adding 2 pi, but this 2 pi is in a form that I can add these. So this will be 12 pi over 3 plus pi over 3, giving me 13 pi over 3. Negative coterminal angles, what am I going to do? So I'm going to go pi over 3 and I'm going to subtract 2 pi, but I'm not going to write it as 2 pi, right? I'm going to write it as 6 pi over 3. What do I get? Negative 5 pi over 3. And then I'm going to go pi over 3 minus 2 of these 6 pi over 3s, which is 1 minus 12, negative 11 pi over 3. Okay, make sense? It's 2 pi, but let's write it as 2 pi in a form that's useful to us. Like 5 pi over 6, what's our 2 pi going to be? It's going to be 12 pi over 6, right? So we just add 12 sixths. So I have negative 5 pi over 6. So if I add 12 pi over 6, will it go positive?
Yeah.
Yeah. And what is it? 7 pi over 6. And if I have negative 5 pi over 6 and I add 2 of these 2 pi's, remember each of these is 2 pi, but we're just writing it in a form that's useful for us for doing coterminal angles, okay, which is equal to 19 pi over 6. And we have negative 5 pi over 6, so what are we going to do? We're going to subtract. What do we get? Negative 17 pi over 6, and then we're going to subtract 2 of them. And what do we get? Negative 29 pi over 6. Okay? You can almost forget the pi over 6 and just let it kind of hang around, right? Because at this point you're saying it's negative 5 plus 12. 7. 7 what? Oh yeah, 7 pi over 6, right? Pi over 6 is an afterthought. It's negative 5 plus 24. Okay, 19. Well, I can't just write 19. 19 what? Okay, pi over 9. What are we going to add? 1 9 down here. What goes up top? 18 pi. Because what am I doing, right? If I'm multiplying the bottom by 9, I multiply the top by 9. And the top is always 2 pi. Okay, you can do these, right? You do them, I'll do them, we'll all come up with the same numbers. And
Are we gonna ever have to like simplify fractions?
simplify fractions. You're always going to have to simplify fractions.
So instead of like.
So by ever, do you mean do we always simplify fractions? Yes. Do we always simplify quadratics when we've got them? Yes. Do we always change an entire radical to a mixed radical? Yes.
So
Always. Do we always rationalize the denominator? Almost always. Not necessarily always.
So instead of 39 pi over 9, we write 6.
That's not a 39.
Or 38, I meant. We write.
Yeah, they're not divisible by 3. You wouldn't write anything. They don't have any common factor.
Oh, okay.
So you can reduce it, but it will end up being, you can't reduce it.
You can subtract.
36, what's this? 56 pi over 9. Okay. Again, irreducible. This is not, the only factors of 9 are 3, and this is not divisible by 3. So you should, if possible, reduce. Then what are we going to do? So what if I try and subtract 18 pi over 9? It's going to be still positive, right? So I'm going to have to go with 2 of these guys. Okay? So when you've got all the, when it's everything's in ninths, then you can immediately see 20 minus 18 is 2. That'll be positive. I want a negative coterminal angle, so I'm going to have to take 2 of these. And 20 pi over 9, and this time I'm going to go with 3 of these. Now that does, but there's, like, don't cancel the 3 into the 9 because you want a 9. So it's just 20 minus 54, right? Is that negative 34? And actually, the easier way to do this is really just from here, just keep subtracting 18. Like, without showing work, add 18, 38, add 18, 56, add 18, 74, add 18, 92, add 18, 110. If I made a mistake, nobody caught it. Right? Like all you gotta do is just keep adding 18s, right? Now it's not 18s, you're adding 18 pi over 9, right? The afterthought is we just, whatever number we're gonna get, we're gonna throw pi over 9 in there as well. 2.6 rad, round to the nearest tenth. All right, so what do we got? 2.6 plus, so in this case we gotta go with 2 pi, which is 6.28. So 2.6 plus 2 pi, and then that's approximately equal to what? So, excuse me, just do it on your calculator. Just go 2.6 plus 2 pi and round it to the 10th. What do we got? 8.9 or 8.8? 8.9? Rad. And then 2.6 plus 2 pi's, okay, which is how much? 15.1 or something? I don't know. 15.0? What is it? 15.2. Rad. Okay, and then we're going to subtract. So 2.6 minus 2 pi, right? And if for some reason you don't get a negative, then just keep subtracting 2 pi's. And then 2.6 minus 2 pi's, which is negative 10.0 radians. Okay. So the idea is we're just adding or subtracting 2 pi's. The idea that we want to start thinking is, but if there's a denominator, then I want to write my 2 pi with that same denominator as an equivalent fraction. Just makes life easier, right? Like, let's do the conversion once and say it's 18 pi over 9 instead of every single time saying, oh, this is 36 pi over 9. Or state all angles beta, coterminal with 2 pi over 5 from negative 4 pi over 5 to 5 pi. Okay, negative 4 pi. If I want to write that over 5, what does it become? 20. So it's negative 20 pi over 5. And if I want to write this with a 5 on the bottom, what does it become? Okay, that makes life easy. And then 2 pi is equal to what? 10 pi. So you got 2 pi. So you subtract 10 pi, you get negative 8 pi. Okay, that's good. Subtract 10 pi, you get negative 18 pi. That's good. Subtract 10 pi, you get negative 28 pi, out of range, or out of domain. Add 10 pi, you get 12. Okay, 12 is good. Add 10, you get 22. 22 is good. Add 10, more than 25, stop. Right. Yep. So when you write your domain restriction in fifths, it makes a lot easier because you know when to stop. Right? You're not constantly having to say, how does that compare to negative 4 pi? Because we know what negative 4 pi is. Right? So what are we going to write here? So like 2 pi over 5 minus 2 10 pi over 5s is negative 18 pi over 5. Actually, you know what? I'm not even going to do that. It's 2 pi. It says state. State means I do not have to show work. So here's 2 pi over 5. Let's throw a comma in there because we know there's something before. Subtract 10 pi. Here's negative 8 pi over 5. Subtract 10 pi. Here's negative 18 pi over 5. Add 10 pi. Here's 12 pi over 5. Add 10 pi. Here's 22 pi over 5. Stop.
You said when you state the coterminal angles of an angle, you don't mention the original.
You do not mention the original. So yeah, so we should not have this in here. So you're right. Take that out. So, you know, pencil it in lightly, you know, do your stuff. Yeah, you're correct. Write an expression for all angles coterminal. So it's 2 pi over 5 plus, now here's what we write. We just write 2n pi. Right? Just say multiples of 2 pi, where n is an integer and n is not equal to 0 because the angles are not coterminal with themselves. Okay. Now, at times we're asked for a general solution, then you don't say the n can't be 0. You just say that's part of the solution if that's the case. But these are coterminal angles. Okay. Is there more on this? Or is it? It's done. All right, let's move on to arc length. We just have the one page. The back of that page is exercises. You've got 3 days. It's wonderful. You have a ton of time to work on them. And then there's some homework as well. Arc length. So, remember, 1 radian is the measure of the central angle subtended by an arc equal in length to the radius. Like here's 1 radius, say here. So this angle is 1 radian. How do we find the measure of other angles? The circle shown has a radius of r units. If the length of the arc is 3r, then the radian measure of the central angle subtended by AB is how much? How many radians? So if lengths, if 1 r is 1 radian, then 2 r's would be 2 radians, and 3 r's would be 3 radians, okay? So the radian measure is 3, okay? I could put 3 without writing anything there, right? Because a number written as an angle measure without any units is assumed to be in radians, okay? And the reason you do that is just say, why? Well, because it's 3r divided by r, right? It's like, how many radiuses are there? There are 3 of them. If we went pi of them, then it would be pi r. That would be halfway around the circle, right? We know that. Circle shown has a radius of r units. If the length of AB is equal to a, then write an equation that relates a, r, and theta. So the angle is equal to what? So what's the arc length now? A. And what do we do with the r? Right. So we're just saying how many radiuses, I think the proper plural is radii. So how many radii are there? Well, it's a divided by r. Okay, so if a is 3 radii, then 3 radii divided by r is 3 radians. If we were halfway around the circle, that arc length would be pi radians, right? So it'd be pi r, right? Halfway around a circle is pi r. Circumference 2 pi r. Halfway around is pi r. Pi r divided by r is pi. That gives us that angle, right? A half circle angle, or 180 degrees. Okay, anyway, this is so important it's on your formula sheet.
So isn't AR or A?
AR over r? No, it's just A over r. No, the arc length is A. Right? Like in the other one, the arc length was 3r. We said there are 3 radius. This is just, here's an arc length of A. What's the angle? A divided by r. Definition. The radian measure of any angle is equivalent to the measure of the arc length divided by the radius. Important thing. Theta. The angle must be in radians.
That means arc length is r theta.
Yeah, you can rearrange this. Well, wait, that's here. Okay, now that you've spoiled it, let's write it in. So yeah, A equals r theta. So this formula relates 3 things. Angle in radians. Must be in radians. Can't use degrees. Okay? Degrees gets you a ridiculous answer when you start thinking about it. Because 60 degrees, if you're pretending that's radians, that's like 10 times around the circle. Okay, not quite, but it's like 9 times around the circle. 60 degrees is about a radian. Okay. So, angle must be in radians, arc length is in whatever units you happen to be using, and the radius is in the same units. These guys must be in the same units. Okay? Because radians is unitless, right? So if I have 10 centimeters divided by 5 centimeters, it's 2. Right? Not 2 centimeters when you divide. Okay, and if A is equal to R, so if the arc length is a radius, then theta is r over r, or 1 radian, right? That's the definition of 1 radian, when the arc length is equal to the radius. Which is why we could talk to the aliens about that, because it's in terms of things which belong to the circle. It's not like there's 360 of these things in a circle. Really? Okay, and your typewriter's laid out funny too, because it's actually designed to be the most inefficient way of typing.
It is.
Yeah, it goes back to the original typewriters with little arms that came up, and if you typed too fast, they would jam. So then the inventor said, well, I got to slow you down, right? Like, what's the most common letter in the English alphabet? E. So E should probably be, most people are right-handed, dominant finger, so E should probably be under your right index finger. It's your dominant finger on your dominant hand for most of the population. Or, at worst, the left index finger. It's still a dominant finger, right? But where is it? It's like, let me take my middle finger and reach up here, right? Q-W-E-R-T-Y. It's called the QWERTY keyboard. Yeah. So there's a keyboard called Dvorak, and you can set your computer to change the keyboard. Dvorak is much more, it's much faster. You can type faster on the keyboard. The only problem is it's really tough then to go back and use any other keyboard because they're not arranged that way. So we have decided in the interests of compatibility to rank inefficiency above efficiency. All right, what's the measure here? So the angle theta. So here's your formula. Here's the secret to math. Sorry, I should have told you like 2 units ago. What's the secret to math? Formula, substitution, got real quiet, answer, right? So, give me the formula you're using, whether it's the quadratic formula or whatever, right? All you're doing is communicating to somebody, hey, I'm using this formula. This formula is angle, arc length, and radius. Then I'm going to substitute in. So give me the actual formula. Don't just start substituting in. Actually write the formula. It's a way of communicating with everybody, including yourself, right? You're saying, I'm going to use the quadratic formula. So here it is, x equals negative b plus y squared, b squared, all over 2a. And I'm going to write it down. And then I'm going to tell you what A, B, and C are. I might even say that before I write the formula. And then I'm going to substitute in. It's hard to make a mistake that way. I mean, we all still find ways to make mistakes, but it's harder to make a mistake. So here's the formula. Then we plug in theta. The arc length is 6 inches. The radius is 2 inches. So what's the angle?
2 inches cancel out.
Inches cancel out because radians is unitless.
Isn't it 3?
Yes, 3 inches.
Oh, it's 3. 3 inches. And the answer is 2. Now if I want to put units on, what do I do? Radians. So you can write the word radians, you can write rad. You like rad. Math is rad. Yeah. I'll get a t-shirt. Math is rad. I don't have a math is rad t-shirt. It's Doctor Who Wednesday. The circle has a radius of 5 centimeters. 5 centimeters. If the arc subtending a central angle has a length of 22 centimeters. Is that more than half or less than half? That's more than half, right? Yeah. So the circumference of this circle is 10 pi. 10 pi is like 31. Half of that is like 15. So 22 is down here, right? So here's my arc length. Oh, let's write that in as 22 centimeters. Okay, so what's my angle? So theta is equal to the arc length divided by the radius. Since the units are the same, we don't need to write them in. Just be cognizant of one is in inches, one is in centimeters. You got to convert them both to the same units. Okay, and 22 over 5 is 4 and 2/5, or 4 point, what's 2/5? 4.4. So 4.4 rad, or 22 over 5 rad. Okay. Now either of those are exact values. I think we tend to prefer the fraction 22 over 5. Okay. If that was 22 over 3, then the exact value would just be 22 over 3. I would not be writing a repeating decimal. Don't write repeating decimals as... Okay. The circles shown have a radius of 5 units. For each circle, determine the length of the minor arc. What's a minor arc? How big is it? Or how big isn't it? Less than half the circle. So a minor arc. So this is a non-minor arc. What word do we use instead of non-minor? Because that's pretty awkward. It's a major arc. Okay, so minor arc up to, this is in your previous stuff. Minor arc is up to half a circle, and major arc is over. Okay, for each circle, determine the length. So what do we got here? So angle AOB. Here's angle AOB. And we know the radius is 5 units. So what's the angle? Ask for the angle or the arc length? What's asked for? For each circle, it wants the length of the arc. Okay, we know what this angle is, right? What's this angle? 90 degrees. We don't do degrees, I'm sorry. It's what? Pi over 2. If you're going to use the formula, so we want to work out the arc length, which means we need the rearranged formula. A is equal to r theta. Okay, and theta must be in radians. Okay. So then A is equal to 5 and that's pi over 2 radians. Okay, so A is equal to 5 pi over 2. Units, whatever the units are, right? Like if it's centimeters, it's centimeters. It just said units, so we're in units. Let's change this. Let's make it 5 centimeters. Then now we have to put the units on, right? We have to say centimeters. Okay. In theory, you should say units. It's 5 pi over 2 units. Exact value rounded to the nearest hundredth. Okay, it's pre-worked out on here. So A is about 7.85 in centimeters. So I'm going to make it centimeters, so we actually are forced to write some units. Angle AOB. There's angle AOB. Oh, so what? This was pi over 2 radians. What's angle AOB?
Pi.
Pi. Okay, so half around the circle is pi radians. So A equals r theta. A is equal to 5 times pi. No, it's 5 pi, and it's centimeters. And then if you want that rounded, it's 15.71 centimeters, approximately equal to. Angle AOB, this time they give us AOB, which is what, this? 120 degrees. So then we just throw down A is equal to r theta, which is 5 times 120, which is 600 centimeters. Does that make sense? No, you can't do that. It doesn't make any sense, right? Because look, this is 5 centimeters. This is 5 centimeters. This is a little bigger than 5 centimeters, but not that much bigger. Yeah, so that's why we can't use degrees, right? 120, that's actually radians. That's like 20 times around the circle, right? A bit shy of 20 times around the circle. So no, we can't do that. So when you see this, you say, okay, I got an angle of degrees, I got to convert it to radians. So what's the conversion? 120. Now, we must use the following pi and 180, right? So I'm going to put the 180 on the bottom because degrees will cancel that way and the pi up top. So that's 120 pi over 180. In a small sense, it doesn't matter if you left it like that. I mean, it's an intermediate number that is going to be simplified out anyways. It's still nice to simplify, right? So you go, well, that's 12 pi over 18, and hang on, they're both divisible by 6. It's 2 pi over 3. Okay, you wouldn't necessarily have to do that because we're looking for the arc length, and whether you multiply by 120 pi over 180 or 2 pi over 3, when rounded to the nearest hundredth, your arc length is your arc length. Okay, so A equals r theta, so A is 5 times 2 pi over 3. Right, that's 5 over 1, so A is 10 pi over 3. If you'd gone 600 pi over 180, you'd have to reduce 600 over 180 to 10 over 3. Very easy on your calculator, right? Just go 600 divided by 180, math, enter, and it'll give you 10 over 3. Because it'll reduce the fraction for you. Okay, question. So big thing, right? The fourth step in the four-step problem-solving method. Step 1 is understand. What am I supposed to do? What have they given me? Step 2 is plan. What's the plan? I'm going to use this formula. Okay, and then I got to change this to radians. Okay. Step 3 is to do it. Do it, and step 4 is to look back. Does that make sense? What's 10 pi over 3? Well, 3 and pi are about the same, so it's really about 10. Okay, I could see how that might be 10. It's not quite, it's a little shy of 10, but it's like close enough. I don't see how it's 600. How's that 600? The whole way around the circle is like, 10 pi is like 30 centimeters, so that doesn't make sense. If the arc subtending a central angle of 13 pi over 15. So how big of an angle is 13 pi over 15? Is it bigger than half a circle or smaller? So in 15s, what's this angle? That's 15 pi over 15. Okay, so we're going to be a little bit shy of that. So here we go. So here's 13 pi over 15. Right? So I think, a chunk of this unit is just always getting your denominator correct, right? Let's all work in the same denominator, and then questions become that much easier. So if the arc subtended has a length of 52 inches, so this is the arc, and this is 52 inches, then determine the length of the radius. Express the answer as an exact value, and then round it. All right, so I'm going to go with theta is a over r, because that's the formula they give me. And then I'm going to change that to r is equal to theta over a, which is the correct rearrangement, I hope. Yeah. Okay, pretty sure. Yeah, it is. Okay, so r is equal to theta over a. I'm trying to get the radius. So here I've communicated to, I'm looking for the radius. Okay. And so r is equal to 13 pi over 15 divided by 52.
It's A over theta.
A over R.
Oh, theta is a over r, isn't it?
Yeah.
Okay, this is why it's just a perfect example of why you use your formula sheet. Theta is equal to a over r. See, you think you know formulas and you don't, and then, so that formula sheet you get on every test. Anybody look at it yesterday? I don't think you need to really, but yeah, eventually you're going to start looking at it. And if you pull it out and look at the trig, it's like half the formula sheet is trig. Okay, that's all the stuff you don't have to memorize. All right, what's r equal to? A over theta. Okay, now we are correctly communicating. So A was 52 and theta is 13 pi over 15. So it's 52 times the reciprocal, 15 over 13 pi, which is 60 over pi. Right? 13 goes into 52 because there are 13 cards and 4 suits and 52 cards in the deck, so 15, yeah, okay. So it's 60 over pi. That's exact. And then you want it to 2 decimal places, which is, where is this here? 19.10. So if they want 2 decimals, you give 2, right? So it's 19.10 in the units. Inches. Okay, so watch out. Don't just start throwing down centimeters or meters. It's always centimeters or meters. This one is in inches. Okay, so exact value. Oh, this also needs inches then, right? There's units on this. It's a radius. A radius has units. Okay, questions? Comments? Concerns? 2 points, A and B, lie in a circle of radius 8 centimeters. If O is the center of the circle and angle OAB is pi over 6. Okay, so pi over 6 is not too huge of an angle. So this is A, and this is B, and this is O, and this angle is pi over 6. And what else do we know? This is 8, and this is 8. Okay, then determine the length of AB. Express the answer as an exact value and as a value rounded to blah blah. Okay, wait, did I get the right angle OAB? No, I did OAB. I did OBA. Angle OAB. This is pi over 6. And we want the length AB, so actually we're not looking, so it didn't say arc length, we're actually just looking for the straight line length. Let's clean that off. Okay, so there's B, and there's A, and this is pi over 6, and we're looking for the straight line, right? Because it didn't say the length of the arc AB, it says the length of AB, which is a line. Okay, that's 8, which means what kind of a triangle is this? Isosceles. So what's this angle here? Same. Pi over 6. So what's this angle here? What are the 3 angles in a triangle always add to? Pi. Right? Well, now it's pi. It used to be 180, but we don't do degrees so much anymore. So it's pi. So I've got 2/6. So how many more 6 do I need to get to 6/6? 4/6, but that's really 2/3. So this angle here is 2 pi over 3, based on...
So on this worksheet it shows the whole article page,
So, oh, that shows an arc? Oh, I see. Okay. Well, anyways, we needed that information that we had to get the central angle. Now we can work out the arc length. Okay, so we had to draw this triangle to get these guys, and then get the central angle, and now we're good. We've got the central angle, radians, we know the radius, and we want to work out the arc length. Okay, what was the formula? theta is A over R. Okay, is that the correct formula? Okay, I got that right. What are we trying to find? We're trying to find an arc length. So A is equal to R theta. And so A is equal to 8 times 2 pi over 3. So the arc length is 16 pi over 3. And what units are we measured in? Centimeters, right? And to the nearest hundredth, then, 16 pi over 3 is 16.76 centimeters. Okay. We're good there. Sometimes it's like learning a new language, right? You say, oh, that's 30 degrees, right? So 30 and 30 is 60, that's 120, and 120 is 430, so it's 4.
So if you put pi for this one,
Yeah, angles in a triangle add up to 180 degrees or pi. Okay, and so the information we were given was, because we were given the angle OAB here, that's a straight line, but we're asked to find the arc length here. So there was that little arc length thing over there, and that's what we're asked to find. But to get the arc length, we needed to get the central angle. To get the central angle, we needed that angle, isosceles triangle, etc., etc. A small child sits on the edge of a merry-go-round as it revolves. The radius of the merry-go-round is 5.6 feet. 5.6 feet. By the time the merry-go-round stops moving, the child has traveled 300 feet. Okay, the radius is 5.6 feet. What's the approximate circumference? Like 11.2 pi, 33, 35, around there, around 30-ish. It's gone 300 feet, so it's gone around about 10 times. Now that's just estimation, right? That's for part 4 of the problem-solving method, which is look back. So in the end, if I say, all right, that's 5.6, the circumference is 2 pi r, 2 of these guys is 11.2. 11.2 pi is 33, it's a bit more than 30, call it 40 maybe. So it's gone around about 7.5 times, right? Somewhere in that neighborhood. So when I get an answer in the end and I say, oh, it's gone around 37 times, it's like, wait, no, I don't think so. Because that distance, that's the look back. The answer that I get at the end, does that make sense? Okay, so in this case, we're saying 7 to 10 times. Okay, so let's try it out. So determine the total angle of the rotation in radians and in degrees rounded to nearest 10. So we know we're going around more than once, right? We're going around about 7 to 10 times. So the angle in radians is going to be, what, about 2 pi, like 14 pi, 20 pi, somewhere in there. Okay, so let's see what we get, and then we'll say, okay, good, that doesn't surprise me, it's what I expected. And then we'll get it in degrees. Okay, so what's theta? A over R. What do we know? We know this and this. So theta is 300 feet over the radius, which is 5.6 feet. Okay, we don't need to write the units on this. So what's that work out to? Yeah, so does it want exact? Determine the total angle rotation, and so it's 300, so it reduces to, I mean, this becomes 3,000 over 56, which ultimately becomes 375 over 7 radians. Okay, but more useful to us, so it's to determine the total angle of rotation in radians. Okay, so there's the angle in radians. Okay, that's exact, and in degrees rounded to the nearest tenth. So we could do this. That's exact. It's 53.6 radians rounded to the nearest tenth. Okay, and then if I'm going to do the conversion to degrees, we could do the exact, the 375 over 7, take that to degrees and then round it. That's probably the best. So 375 over 7 radians times, so I need a 180 and a pi. What goes what? 180 on top. That's what I want. The thing I want goes on top. I want degrees. And the thing I have goes on the bottom. I have radians. I want degrees. So one radian is 180 degrees divided by pi. 180 divided by pi degrees. Okay, so we could just work that out, get it as a decimal, right? Round it to the nearest tenth. So 375 times 180 divided by 7 divided by whatever, and it's nearest tenth. So what do we get? 3071 point. No?
I got 3069.
Yeah.
3069 point. 3069.4 degrees. So that's 360. It's a little shy of 10 times around, but that's what we were figuring. Somewhere in there, right? You take 53.6 divided by 2 pi. It's going to be a little bit shy of 10 times around. How many times around is it? What's 8.5, right? So we said between 7 and 10. So 8.5 is like right between 7 and 10. Okay, so you want an idea, right? The look back part of it is when you go and you write, that's 536 radians. It's like, wait, that's 536 divided by 2 pi times around the circle, and this circle has a circumference of this. No, that can't be. Right? So you can work it out. I think that's it, isn't it? Yeah, so next page is exercises, yeah? So we're done.